Good morning, children. In logarithms, we have learned definition of the logarithms and properties of the logarithms and laws of the logarithms. Now, we are going to learn the comparison of the logarithms. Comparison means if two logarithmic numbers are given, whether those two are equal or first one is greater than the second one or first one is less than the second one. How to compare? How to get the symbol between them is equal to, less than or greater than. So, to compare the logarithms, we have to know logarithmic equality. When do you say two logarithms are equal? Logarithmic inequalities. When do you say two logarithms are not equal? So that children, first let us see logarithmic equality. Logarithmic equality. Let x comma y comma a belongs to R plus, that means all are positive real numbers, and also a not equal to 1, because of I am going to take a as the base of the logarithm, that's why a not equal to 1. Now, if x is equal to y, if and only if log x to the base a is equal to log y to the base a. This is known as logarithmic equality. Whenever two logarithmic numbers are equal with the same base, then the logarithmic numbers also equal. Now, proof. How to prove this one? Let us take log x to the base a is equal to log y to the base a is equal to some k. Let log x to the base a is equal to log y to the base a is equal to k. Then write it in an exponential form. X is equal to a power k, comma y is equal to a power k. Therefore, from this we can get x equal to y, because of x equals to a power k and y is also a power k. Therefore, we will get x is equal to y, and vice versa also. By taking x equals to y, we can get log x to the base a is equal to log y to the base a. Now, using this equality of the logarithms, we can compare two logarithms. Next, let us learn logarithmic inequalities. Logarithmic inequalities. Logarithmic inequalities. Here also, let x comma y comma a belongs to R plus and a not equal to 1, because of I am going to take a as the base. If x greater than y and a greater than 1, then log x to the base a is greater than log y to the base a. What do you understand? What do you understand? Whenever x is greater than y and the base is greater than 1, because of a belongs to R plus and a not equal to 1, we can divide that interval into two parts. Let us see here. this is 0 and it is 1 and more than 1 this is. In this interval we can take the values, a values between 0 to 1 and a values between 1 to infinite. It doesn't take 0. Dotted lines here, dotted line means it doesn't take 0. That base doesn't take 0. Here also, at 1 also dotted lines are there. That means it doesn't take 1 also. Base should not be 1. That's why a not equal to 1. Therefore, we can divide the base interval into 2 intervals. One is greater than 1. That base is greater than 1 case. Base lies between 0 and 1 case. That's why here 2 cases will be raised. If x greater than y, a greater than 1, then log x to the base a is greater than log y to the base a. Children, remember, whatever the inequality between these two numbers, their logarithmic numbers also carrying same inequality if base applied is more than 1. Very important point that is. We are going to prove it also. This is first one. Second one. If x greater than y, here also x greater than y, but base, what is the other interval of the base? 0 less than, a less than 1. Then inequality between the logarithms will be changed. Here x is greater than y. That's why here log x to the base a is less than log y to the base a. From these two, we can understand one point. The same inequality carry out between the logarithmic numbers also if the base is greater than 1. The inequality will be changed if the base lies between 0 and 1. Children, for example, I am taking 5 is greater than 4. I am going to apply the logarithms for that inequality with base 7. Now, what will be that inequality? Is it carrying the same inequality or not? Yes, it is carrying same inequality because of I am applying the base 7. Then it becomes as log 5 to the base 7 is greater than log 4 to the base 7. What is the reason here? The same inequality carry out here also because of this base is greater than 1. That is the reason. Now one more example. 5 is greater than 4. I am going to take logarithms on both sides. I am going to apply the logarithms on both sides with the base 1 by 2. Then how this inequality becomes? Log 5 to the base 1 by 2. Log 4 to the base 1 by 2. Using the second result, because of here base lies between 0 and 1. That's why the symbol will be changed. Here greater than is there. Now inequality will be changed as less than. Log 5 to the base 1 by 2 is less than log 4 to the base 1 by 2. Is it clear, children? Now come to the proof of these results. First one, if x greater than y, a greater than 1, that implies that log x to the base a is greater than log y to the base a. Let log x to the base a is equal to some p. Log x to the base a is equal to p, exponential form. A power p is equals to x. Similarly, log y to the base a is equal to q. That implies that a power q is equal to y. Now take this one, x is greater than y. Given x is greater than y. What is x? A power p is greater than a power q. In the laws of exponents, we have the exponential inequality, that is, whenever the base is greater than 1, given that base is greater than 1, base is a is greater than 1, then the inequality between the powers doesn't change. Whatever the inequality between the exponents, the same inequality will be carried out for the powers also, since a greater than 1. Now we have p is greater than q. That implies that p is greater than q. What is p? Log x to the base a is greater than log y to the base a. Come to the second result. Similarly, we can do second result also. If x is greater than y and 0 is less than a is less than y 1, then what do you observe? The inequality will be changed. Log x to the base a is less than log y to the base a. Why? Because of a lies between 0 and 1. Now proof. Same proof. Log x to the base a is equal to p, a power p equals to x. Log y to the base a is equal to q, then a power q equals to y. And given that x is greater than y, that implies that what is x? A power p is greater than a power q. And also 0 less than a less than 1. Now bases are equal, and base lies between 0 and 1. What is the relation between p and q? What relation we have between the p and q? Which is greater than? P is less than q. Inequality will be changed. For example, 0.1 whole cube, 0.1 whole power 4. Which is greater? 0.1 whole cube is greater. But between the powers, what is greater? 3 is greater than 4 or 4 is greater than 3? Therefore, here inequality is greater than, but between the powers, the same inequality doesn't carry out. Why? Because of here base lies between 0 and 1. That is the reason. Therefore, whenever base lies between 0 and 1, then between the powers, the inequality will be changed. Whatever the inequality the exponents has, opposite inequality will come between the powers of the exponents. Is it clear, children? Then we have p less than q. What is p? Log x to the base a is less than log y to the base a. Using this knowledge, logarithmic equality and logarithmic inequality, we can compare the logarithmic values, and we can solve the logarithmic equations also. And with the help of this knowledge, we can able to find the signs of the logarithms also. Let us see signs of the logarithms. Signs of the logarithms. Children, what is this sign for log 3 to the base 2? Is it positive or negative? What is the sign of 3 to the base 0.2? Log 3 to the base 2, log 3 to the base 2, is it positive or negative? Plus or minus? Is it positive or negative? Plus or minus? How can we decide it? To decide the logarithmic signs, it should be compared with 1. Between these two, which is greater? It should be compared with 1 means we have to compare the base and the logarithmic number. You should compare with 3, 1, which is greater? 3 or 1? 3 is greater than 1. Now apply the logarithms with the base 2 on both sides. What do you get? Log 3 to the base 2 and log 1 to the base 2. What inequality carry out between these two? Already we have learned logarithmic inequalities. Using that knowledge, what inequality between these two? What type of inequality will come? Same inequality will come. Why? Because of here base is more than 1. That's why here log 3 to the base 2, log 1 is nothing but 0. Therefore, log 3 to the base 2 is positive. Wherever come to this result. Now how to compare again 3 with 1. 3 is greater than 1. Now apply the logarithms on both sides with base 0.2. Then log 3 to the base 0.2 and log 1 to the base 0.2. Which inequality takes place between them? Applied base is 0.2, which lies between 0 and 1. That's why the inequality will be changed. Then it becomes as log 3 to the base 0.2 less than log 1 to the base 0.2. Then log 3 to the base 0.2 less than 0. Therefore, it is negative. And also, one more example if you consider. Log 0.3 to the base 2 and log 0.3 to the 0.2. Here 0. Compare with 1 only. 0.3 is less than 1. Apply the base, apply the logarithms on both sides with the base 2 because of base 2 is required there. Therefore, then it becomes as log 0.3 to the base 2 is less than 0. Why? Because of applied base is greater than 1. That is the reason. Now, finally, if you come to the 0.3 is less than 1, apply logarithms on both sides with the base 0.2. Then inequality will be changed because of base lies between 0 and 1. By observing these 4 examples, we will get one conclusion, that is log a to the base b is positive if both are greater than 1, a greater than 1, b greater than 1. Otherwise, are 0 less than a less than 1, 0 less than b less than 1. Both are greater than 1 or both lie in between 0 and 1. By observing those 4 examples. Is negative, log a to the base b is negative if a greater than 1 and 0 less than b less than 1 or 0 less than a less than 1 and b greater than 1. That means either of these two lies between 0 and 1, other one is greater than 1. Children, by seeing the, without following any process, by seeing the logarithm, now we can able to say its a sign very easily. Log 3 to the base 1 by 3. what is its sign? Using these conditions, here 3 is greater than 1, 3 is greater than 1, 1 by 3 lies between 0 and 1, that's why it is negative. Very easily you can decide. Now come to problems depend on logarithmic inequalities and equalities. Let us see one problem. Log x to the base 5 is equal to log 4 to the base 125. Find x, that is the requirement. Children, once observe, can we compare these two using the logarithmic equalities? Before compare these two logarithms, we have to make bases should be equal. Here what is the base? Here what is the base? 5 is the base. Here what is the base? 125 is the base. So that make these two bases are equal. Then it becomes as log x cube to the base 5 cube. 3 by 3 is raised there because of in front of them write 3 by 3 and 1 3 comes as the power of the x, 1 3 comes as the power of the base. By the base and logarithmic power formula, which is equal to log 4 to the base 125. That implies that log x cube to the base 125 is equal to log 4 to the base 125. Now bases are equal. Since bases are equal and in between them is equal to sign is there, therefore according to the logarithmic equality we have x cube equal to 4. That implies that x equal to cube root of 4. This is the value of the x. Now come to the next problem. Determine the inequality between 1 and the following: log 7 to the base 3. 1 and the following, that means I am going to compare log 7 to the base 3 with 1. To do such type of problems, comparison with 1, we have to compare base of the logarithm and the logarithmic number, that is which is greater 7 or 3. 7 is greater than 3. 7 is greater than 3. That implies that apply logarithm on both sides with the base 3, then it becomes as log 7 to the base 3 is greater than log 3 to the base 3. After that it will come as log 7 to the base 3 is greater than 1. Using inequality of the logarithms only, we can able to compare the logarithmic number with the 1. In this, we have to remember a process that we have to compare the logarithm base of the logarithm and the logarithmic number, and after that apply logarithms on both sides with the given base. Then according to inequality of the logarithms, we can able to get what inequality takes place between the two logarithms. Here base is greater than 1, that's why the same inequality carried out. Then log 7 to the base 3 is greater than 1. This is aim number 4.